All right, so hi everyone, how are you guys doing? So first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT. And on this particular channel of YouTube, you are being taught every concept of physics, chemistry, and maths completely in English, so that those students who are slightly uncomfortable with extensive usage of Hindi and all the online content available on YouTube can feel relaxed. Okay, so this is the series that I host for class 12 students, and here we are trying to quickly revise all the important class 11 topics. So this is topic that we are going to discuss today is waves. This is quick review part 2 of waves. Now, before we move ahead with today's discussion, let me introduce myself for those of you who might not know me yet. Okay, so my name is Rohit Dixit, and I studied. All right, so here we go. So those of you who don't know me yet, my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. And for almost past 8 years now, I've been teaching physics for the IIT JEE Mains and advanced examinations. Now, before the previous year, all my experience was in the offline setups, and last year only I started teaching online for the first time. And let's see how it goes. So I myself, as a student, was All India rank 447 and All India rank 1 and 2 in the two stages of the IIT JEE exams that I took. Now, I also qualified the NTSC Stage 2 as a student, and I was in the top 1% in the NACP. I've already coached many students to top ranks in the IIT JEE exams, both mains and advanced. All right, sure, Swagger Samir. That is why this channel was launched. Okay. So again, and let's hope I now hope to continue guiding you guys to your dream colleges and dream ranks through this new channel online. Okay, so any student who is worried about how they can make the most of this time and ensure that they are not missing out on their studies and they get to their dream ranks and dream colleges, so they can get Unacademy subscription. So this subscription will give you benefits like live classes where you get to interact with your educators on a regular basis. Then, of course, these classrooms also have live polls and leaderboards, and you have regular tests, series and analysis sessions, and you have live doubt clearing sessions. So, those of you who don't know this, for all Unacademy Plus courses, after every 3 teaching sessions, one session is dedicated entirely to your doubt solving. So, after every 3 teaching sessions, a student can ask away any kind of doubts that they may have about their preparation or any concept that they did not follow or any problem solving difficulties that they are following. Okay, so again that's a huge advantage with this subscription. Now, along with that advantage, now the next advantage that you get is that you get the chance to study from the topmost educators from all across the country from the comfort and safety of your home. All right, so how do you get these benefits? So the first step involves you to install the Unacademy app. Okay, so this is a very simple thing, and the moment you do that, you will realize you will unlock for yourself a lot of free features. So there are free courses which are running on the Unacademy app, which you can simply attend just after installing the app. Then there are special classes like one I just took. So all the educators almost take special classes which are free to attend for all the students who have got this app installed. And then of course you have free quizzes. So these are the free features which you can start availing right away just after installing the Unacademy app. To avail all these features, all you need to do is install the app and use my code RD Live to unlock all these features. Okay, so that is all it takes. Now, once you start using the free features and start benefiting from them, so you will also realize how your preparation is going to be with your Unacademy subscription plus subscription. So when you finally decide to get yourself that plus subscription, this is how you can go about that. So you can go to the plus section of the app, select your goal as ITJ, and click on the get subscription button. Okay. Now, when you do that, you will be redirected to the payment page where you will see a box which will say, do you have a code? So that is where you can enter this code, RD Live. This code will give you a 10% off on all your subscription fees. And now you can choose from two kinds of subscriptions, Plus or Iconic. The fees of these subscriptions are mentioned here. And you will also realize once you click on proceed to pay, you can also break this payment into a lot of low cost EMI options. Okay. So that you do not have to face the burden of making that entire payment in one go. Okay. Next, for those of you who are not aware as to what the Iconic subscription is, so here is a slight bit of description of that. So the iconic subscription is the new feature being offered by Unacademy, and this subscription takes your IIT JEE preparation to the next level. And how does that happen? You are allotted personal coaches from our team of experts, and so these personal coaches will closely monitor your performance and guide you throughout your IIT JEE journey. And of course, along with that, you get to attend a lot of IIT JEE workshops, receive expert guidelines from time to time, get a study planner, which I think is very, very important, which I know a lot of students can definitely use, and then have regular test analysis sessions. Okay. Now, students who have just entered class 11th and who are looking for a single one-stop solution towards all their study needs can go for a combo subscription that Unacademy now offers. So Unacademy is offering you 4 combo subscriptions, and these combo subscriptions will take care of all your study needs, be it your class 11 CBSE studies, be it your class 12 CBSE studies and boards, be it your JEE Mains preparation, be it your JEE Advanced preparation. So all your study needs taken care by these combo subscriptions. So there are 4 combos that are available. The first combo offers you the iconic subscription for JEE and the plus subscription for CBSE 11th and 12th. So this subscription starts at around 4,600 a month. The second subscription offers you the iconic subscription for all 3. This subscription starts at around 5,500 a month. Then the third combo offers you a plus subscription for IIT and plus subscription for 11th and 12th. This combo starts at around 3,000 a month. And finally, you have a combo wherein you get the plus subscription for IIT and the iconic subscription for class 11th and 12th CBSE. And this combo starts at 3,900 a month. So with these combos, again, you can select a combo that suits your study needs and your preparation needs, and then leave all the worries of your preparations behind. Okay. Next, these are the upcoming tests in January, which I don't think you should be missing out on. So the next Unacademy Combat is going to happen on the 31st of Jan live. So do take part in that. You can enroll now using the code RD Live also in that. Okay. Next, you have the race event exam, which is going to happen on the 24th of January. And finally, you have AIM Advanced 2021 series going on, which happens every Saturday. And you have unique DPPs, which are being discussed every Monday through Thursday. Okay. Again, those students who are following us on the JEE English channel of YouTube, do not forget to connect with us on the Telegram app using this link. So a lot of students often complain that they have subscribed to the channel, they have pressed that bell icon also, still they do not receive timely notifications from YouTube. So yeah, that may happen sometimes, but this is a great way to avoid that. So once you subscribe to this channel, so here you will be receiving all timely notifications of every session that is happening on this channel and some other channels of Unacademy as well. Okay, so you will be completely up to date as to whatever content Unacademy is bringing for you. Okay, so that's a great way to keep track of all the content that you do not want to miss out on. All right, so now without any delay, let's get started with today's topic, which is quick review part 2 of waves. Okay, so in the last class, let's take a quick recap. We talked about the general differential equation of the wave, which was given in the form of del 2 y by del t2 equals c square times del 2 y by del x2. Again, c or v, which is the speed of wave, okay, which we realized in our last discussion. Now, the general equation of a traveling wave becomes y equals f of ax plus minus bt. As long as it is a bounded function, it represents a traveling wave. Now, a general equation of a simple harmonic wave. So I told you in the last class that for any traveling wave, there is a disturbance that was created by a source of disturbance which is getting propagated. If the source decides to create a SHM as the disturbance, then a simple harmonic motion is getting propagated throughout the medium, and such a wave is called a simple harmonic wave, and such a wave takes up this kind of equation. Okay, so again, this is the main equation that we are going to focus on. A majorly analysis of this equation is only in our syllabus, but sometimes JEE has asked you questions about this also. Okay, but that is the major point of concern that we are going to focus on. All right, so again, let's quickly go over some formulae of speeds in different mediums. Again, I'm not going to show you the derivations here. So I'm assuming that the derivations are already known. Okay, now let's see. Okay, so in a stretch string, the speed of a wave is given as c equals T over root of T over mu. Okay, again, very important formula that you must remember. For liquids and gases, the formula becomes C equals root of beta over rho, where beta is the bulk modulus and rho is the density. Okay, so let's just write down the terms also. This is the tension in the string, and mu is the mass per unit length. Next, beta is the bulk modulus of elasticity, and rho is, of course, density of the gas. Okay, so these are equations that you must remember. All right, next. Again, if you talk about energy of a wave, hello Hitesh, how are you? Hello AP. Okay, so if you remember the energy density, so let me tell you about that equation. So energy of oscillations per unit volume is what you call the energy density of the wave. Now for SHM, you know the energy is average energy of oscillations is half m omega square a square. Now per unit volume, the mass becomes rho. So the energy density is given as half rho omega square a square. Now next we talk about the power delivered by a wave. Power is the energy transferred per unit time to any surface area per unit area, that is. Okay. So what you realize is that that becomes this. The expression for power becomes this. Again, important formula you must remember. Again, we are not going through the derivations because this is a quick review. Okay, when I take this up for class 11 students, I will show all the derivations also. Okay, in the quick review, we are just going over the formula without worrying about the derivations. Okay, all right. Next, of course, we talk about intensity of a wave. So intensity of a wave is the energy transferred per unit time per unit cross-sectional area, and intensity obviously becomes this. This is the expression for intensity. Again, a very important expression. Okay. So next, if P is the power of an isotropic point source, so if you have a point source of waves which is spreading waves in all directions, okay, so then at a distance r, you realize the power emitted by the source is telling you the energy, total energy per unit time. So per unit cross-sectional area in a at a distance r, this entire energy would have spread over the area of a sphere of radius r, correct? So the sphere of radius r has an area of pi r square. So the intensity at a distance r becomes p over 4 pi r square, okay? Or the intensity falls off with distance as inversely with r square, okay? So that is what you need to remember. Then again, if you talk about the intensity for a line source, so hello, Abe, hello Mahi, hi Motilal, hello Amot, how are you guys doing? If you talk about the intensity of a line source at a distance r, then that falls off at as 1 over r. So what I'm trying to say here is now you have a source which is a line source instead of a point source. So this will spread energy into a cylindrical region, right? So the curved area of the cylinder, you know, is 2 pi r L. So that is why you are getting this kind of an equation. So when this guy is emitting energy in all the directions, it is getting spread over a cylindrical region. So the intensity at a distance r falls with 1 over r. Okay. Next, let's get started with some problem solving. Okay, so let's again, I know mentioning the formula is one thing, but giving you practice is another. So let's practice. Let's put those formula to use. So this will help you remember those formula also, and also see how to apply them. Okay. So here you've been told a stretched string is forced to transmit transverse waves by means of an oscillator coupled to one end. So in a stretched string, at one end you have added an oscillator which is forcing a transverse waves to pass through this string. Okay, now the string has a diameter of 4 mm. The amplitude of oscillations has been given to you as 10 to the power minus 4. The frequency is 10 Hertz. The tension in the spring is 100 Newton. The mass density of the wire is this. So first, you have to find the equation of the wave along the string. Okay. Let's see if you can figure that out. What would be the equation of the string? Then once you have done that, then you are asked the energy per unit volume of the wave, and finally the average energy flow per unit per unit time across any cross section, and finally the power required to drive the oscillator. How much power is the oscillator delivering to maintain this wave? Okay, so come on, people, give it a try. Okay. So what do you need to determine the equation of the wave? The standard form of the equation of the wave is y equals a sine kx minus omega t. Correct. So a has already been given to you. If you could find out k and omega, then you have the wave equation. Correct. So a I was already given. Okay. Amplitude of oscillations is this. Now what I've been told is the diameter of the string. Okay. And I also know the tension in the string. I also know the mass density, and I also know the frequency. Okay. So since I know the frequency, let's see. I know since nu is 10 hertz, I know the omega. Omega is related to nu as 2 pi nu. So omega becomes 20 pi. Okay, so I already got omega. Now what is left for me is to figure out what k is. Now for k, I know it is 2 pi over lambda. If I can figure out lambda, then I will have my k also, and then I can tell you the wave equation. Okay. Now, how do I figure out lambda then? I already know nu. Can I calculate c? Yes, I can. So c, I know is root t over mu, which is tension over mass per unit length. Okay. So I already know the tension, which is 100. I know the mass density of the wire, rho, and I know the cross-sectional area. Okay, because I know the diameter. So can I say mass per unit length, mu, which is mass per unit length, uh, would be nothing but rho times volume per unit length. Volume per unit length would be simply area of cross section into 1. Okay, so that will be rho into pi r square. Okay, so that is how I figure out the mu. So mu from the given data would be rho, which is the density, which is 4.2 into 10 to the power minus 10 to the power 3 into pi into the r radius. The radius diameter is 4, so the radius would be 2 mm. 2 into 10 to the power minus 3 whole square. What I realize is that mu will come out to be 4.2 into 4 pi into 10 to the power minus 3. Okay. So with that mu, now I can calculate that mu, I can calculate the other values. So once I have the mu, I will know that I can now calculate C. C would be equal to root over mu, which would be root of 100 over 4.2 into 4 pi into 10 to the power minus 3. Once I have the value of C, I know lambda. Lambda would be equal to C over nu. So it would be C over 10. 10 hertz was the frequency. Now once I know lambda, I can calculate K also. K is 2 pi over lambda. Now once I know K, I know the equation. Equation is A, which was given to me, sine of kx minus omega t. Omega was 20 pi t. That is how you would have gone about solving this. This you already know is 10 to the power minus 4. Okay. All right. So that is how I would have gotten to the equation of the wave. Now, once I've got the equation of the wave, once this part is done, next what has been asked of me is the energy per unit of volume of the wave. Okay. So I already know the formula for that. For part B, what I'll say is energy per unit volume, I know, is half of mass per unit volume, which is rho, into a square omega square. This is the energy of average energy of SHM. Right. So again, I will substitute all the values here, which I've already calculated above, and I will get the energy per unit volume or the energy density. Correct. Next, let's see what else we needed to find. Next, we were asked the average flow of energy. So we have this also. Next, the average energy flow per unit time across any section of the string. So across any section of the string, what is the average energy flow? So again, that is also very, very simple to find. In across any section, if the wave is traveling with c in dt time, you realize in dt time it would have spread over a length of c dt. So what is the volume in which it gets spread? So energy would become half rho into the area of cross section pi r square into c dt. So dE, this amount of energy to a square omega square. This would have been the amount of energy that passes through, and again, this is the energy that will get provided to this section now. If dE energy crosses a section, then it will go into the section and it will provide it the energy of SHM, correct? So dE by dt, so the energy crossing any cross section, which I had already told you the formula also, but this is the derivation, is rho into area of cross section into a square omega square c. It is part C of our problem. Finally, power required to derive at the oscillator again. So I know the average energy that is flowing across any cross section. So that is the amount of energy that must be coming from the oscillator. Okay, so power required by the oscillator is going to be this only. Is going to be P, which is the answer for. Okay, whatever energy is flowing through the string per unit time is the energy that is being provided by your oscillator. Okay, so the answer of D and C will be the same. So that is how you will approach a typical problem of waves. Okay. Now, if you have any confusion, then you can let me know. Okay. So take a look at the solution. Take a look at how we achieved at different values. We arrived at different values, and let me know if there is any confusion. All right. So let's move forward and let's tackle another problem. Okay, so here you've been told a certain 120 hertz wave in a string has an amplitude of 0.16 mm. How much energy exists in 40 length of the wire? Okay, so again, this will be simple. This should be simple. Lambda has been given to you. The frequency has been given to you. The amplitude has been given to you. You've been asked the energy that exists in 40 centimeter length of the wire. Okay, so try this, and let's see if you can figure this out. Okay. So the idea is whenever a simple harmonic wave is traveling through a medium, it is causing all the medium particles to perform SHM, right? So in this length, all the mass is performing SHM. You know the average energy of SHM, that would be the energy that exists in this region, okay? The total energy of SHM is known to you. Okay, so let's see. Okay, so what is the mass which is oscillating? M would be equal to lambda into L. So that is, lambda was 2 and length was 40, so 80 gram. So 80 gram mass of my string is oscillating. And I know that energy of oscillation, energy of SHM is half omega square A square, correct? So M I already know. If I can figure out omega, then I'm done because A I think has been given to me. Yes, A has been given to me. All I need to do is figure out omega, and for omega, I have been given the frequency. So since I know the frequency, I can say nu equals omega over 2 pi. Therefore, omega is 40 pi. Okay, nu was 120. So I'll just substitute these values here. So what I'll get is energy contained in that portion is this into 80 into 10 to the power minus 3 into omega square, which is 240 pi whole square into a square. A was 0.16 mm. So I'll just simply solve this expression and get my answer. That is the energy contained in a 40 centimeter length of the string. Okay. All right. Now let's move forward. Let's try another question. So the approach is going to be pretty simple only. If you follow the logics, trust me, the questions of waves are not that difficult. I know a lot of students feel that there is so much information, but if you just remember your SHM and if you understand what a wave is, then trust me, these are very very simple. Okay, next, let's try and understand this question. So this question tells you a transverse wave of amplitude 0.5 mm and frequency 100 hertz is produced in a wire stretched with a tension of 100 newton. If the wave speed is 100, find the average power transmitted by the source to the wire. Okay, so essentially you have to find the average power getting transmitted across the string. If you can find that, then that is the average power that is transmitted by the source to the wire. Okay, so let's see how many of you can figure this out. Hmm. So again, the approach of this is going to be exactly same as the last one, last one. Where I had to find the dE by dt. Okay, dE by dt energy that is passing through any region per unit time. I realized what was half rho uh, area of cross section into a square omega square c. Okay, so I know energy power transmitted by a wave is half area of cross section. Let's call that S omega square a square c. Correct. So let's see what all I know. I know the amplitude, so A is known. I know the frequency, so omega is known. So I can say A is 0.5 into 10 to the power minus. Here. What about omega? Omega would be 100 into 2 pi. So 200 pi, that is my omega. Next, what I need, I also know the C, wave speed. Wave speed is 100 meters, 100 meter per second. Next, I needed next I also needed the density into cross section. Now, density into cross section, what is that? This is lambda. You will realize that density into cross section is the mass per unit length only. So you know lambda equals rho into the area of cross section. So you can rewrite this as half lambda omega square a square c. Okay. So since I also know the tension, I know, or mu. I even call this mu. We call this mu per unit. That is the expression for power. Yeah. Now calculating mu is very very easy. You know C equals root over mu. So from here mu would be T over C square. Tension was given to you as 100 Newton, so this will be 10 to the power minus 2. Now you know all the values. You know this. So you know A, you know omega, you know C, you know mu. All you need to do is substitute all the values here, and your power would be 1 by 2 into 10 to the power minus 2 into omega square, which is 400 pi square into A square, which is 0.5 into 10 to the power minus 3 whole square into C, which is 100. Okay, so that is how you just solve this. Okay, again, you could have solved this also. Let's say 200. So 10 to the power minus 2 gets cancelled from here. And what I will pi square in 1 by 4 to 10 to the power minus pi square again can be written as roughly 10. Roughly 10. So this will become plus, this will become 5. 5 into 10 to the power minus 4 watt. That would be my answer. Okay, I hope everybody followed these steps. Next, we will talk about superposition of waves. Okay, so once I have figured out how to analyze wave equation, how to once we understand, how to study waves. Next, we will study about other behavior of waves. So most of the behavior of waves that we are going to focus on all result from superimposition of waves. Okay, so that is going to be the next topic of discussion. So when two or more waves are propagating in the same medium, so can actually propagate in the same medium without affecting the motion of one another. So you can have, let's talk about sound maybe. So you realize if I have a speaker here and if I am talking from here, and if this is emitting some sound and I am saying something, so both these waves are traveling to the mic, and you realize you will hear both the sounds distinctly. So yes, that proves that two or more waves can in fact propagate in the same medium without affecting the motion of one another. Okay. Now, if several waves, however, propagate in a medium simultaneously, then the resultant displacement of any particle of the medium is at any instant is equal to the vector sum of the displacements produced by individual waves. What is happening is, so you imagine there is one wave is trying to cause one kind of SHM, there is another wave, this is trying to cause another kind of SHM. When these two superimpose, so when they reach a point, a particle here, suppose, so one wave is trying to give it one kind of SHM, another wave trying to give it another kind of SHM, the resultant motion would be the superimposition of these two SHMs, which we already studied in superposition of SHMs, right? So this phenomena of intermixing of two or more waves to produce a new wave is what we call the superposition of waves, okay? Now, according to superposition principle, again, you will remember, this is what we used in superposition of SHMs also. So if you have to write the resultant wave equation, it will be nothing but vector sum of all the displacements at any point produced by individual waves. Okay. Next, due to superimposition of waves, you realize a lot of phenomena result. Okay, so there are categorically we talk about three major phenomena which result from superimposition of waves. So first we talk about interference. Okay, so interference is a phenomena that results from superposition of two or more waves traveling in the same direction, having equal frequency and nearly equal amplitudes. Okay, so please note the conditions. So this superposition of waves which are traveling in the same direction, having equal frequency and nearly equal amplitude. Okay. Then you have something called stationary waves or standing waves. These result from superposition of two waves traveling in opposite directions. So two identical waves. Let's add that identical waves. Has to be two identical waves. Otherwise, the standing wave will not be formed. Superposition of equal waves. Okay, so I have said equal waves traveling in opposite directions. So equal means identical, which means they have the same amplitude, same frequency, everything is exactly the same. Okay. Then you have beats. Beats are formed when two by the superimposition of two waves of nearly equal frequency, okay, traveling in the same direction. So if the frequency is exactly the same, then you get interference. If it is slightly different, then you get beats. And if the frequencies are same but the directions are opposite, then you get standing waves. Okay, so these are the few phenomena that we are going to focus on. All right, so let's first start our discussion about interference of waves. Okay, so here is an example that you can easily see. So you realize you had if you throw two pebbles in water, okay, both of them will produce waves, okay, and you realize at different points, you will notice here the resultant motion is essentially coming out as superimposition of both, okay, at these points. Okay, here you can clearly see two waves. Here you can clearly see this wave. Here you can clearly see this wave, but then in this region, they have gotten mixed. This region, they have gotten mixed. In this region, they have gotten mixed. So here you will see a different result. Okay, and that is what interference is. This is an example of interference. Okay. So for interference, we need something called coherent sources. Okay, so again, pay close attention to everything that I'm discussing here. All this is important. So if you don't follow one thing also, then turns out you may not be able to understand all the concepts. Okay, so pay close attention. First, we'll talk about coherent sources. What are coherent sources? So two sources are said to be coherent when the waves emitted by them have the same frequency and constant phase difference. So you realize the only way that two waves can maintain a constant phase difference is if they have the same frequency. Frequencies are different, then their phase difference will change with respect to time. Okay, I hope you realize what is the phase difference. Now let's take a look at the equations also. Let's say this is one wave, and for the sake of simplicity, or okay, and let's assume that there was a second wave which was like this. So I'm taking a generic case only. Let's consider two waves. So at any x, let's say at some x equals x1, what is the phase difference? Delta phi is, this is the phase, right? It is the difference of these two phases. Sorry. So this will be, uh, this will be omega 2 minus omega 1 t plus delta k times x1 plus delta phi naught. Okay, so you realize once my x is fixed, this value is fixed, right? The wavelength doesn't change, so this doesn't change. This value is fixed, and this value obviously is a constant because it is the difference of two constants. Now, for the phase difference to become constant with respect to time, I need to make this term as 0. If this goes to 0, then the phase difference between the two waves would be constant with respect to time. So for that, the condition is omega 1 equals omega 2. So the frequency of the two sources which are equal, so that as a result, they will always maintain a constant phase difference at any point, which won't change with respect to time. These such forces are called coherent forces. Okay. Now the interference phenomena, for interference phenomena to be observable, the two sources must be coherent. As I said, if the frequencies are different, then the phenomena that results is beats. Okay. For interference phenomena to be observed, the two sources must be coherent. Okay. Now, resultant amplitude of coherent waves. So let's talk about superposition of two coherent waves. Okay. So now, in most of the cases, if the waves are traveling for one medium through one single medium, so you realize the C is same, right? C is a property of medium. So I hope you guys know this, that the speed of the wave is a property of the medium. Wave speed is a property of medium. So you realize any transverse wave traveling through a tight string has a speed of root t over mu. It doesn't matter what kind of what is producing that wave. It may be given by this equation, may be given by this equation. You realize whatever be the frequency, the speed is going to be always the same. Okay. Now, what I realize is if I have two coherent waves, then omegas are same, and if omegas are same and c is same because both are traveling in the same direction, then your k would also be the same. Okay, so for coherent waves, I will have equations where the k and the omega of both the waves will definitely be the same. Okay, so any phase difference that they can have, they will have this kind of equation. Okay, so Arnav Goyal had written a long sentence and then he just deleted it. What happened, Arnav? Okay, all right. Anyhow. So now you already, if you remember our analysis of the superposition of SHMs, so you realize if this kind of superposition can be done by adding the two phasors. The two phasors of A1 and A2 are at a phase difference of phi. Okay, so you realize the resultant amplitude would be given like this, and then the angle theta which this phasor will make with A1 is given by this. Okay. Once I know this A and theta, okay, so Arnav is saying, sir, should we study communications for KVPY? It isn't mentioned in the syllabus, but one of these syllabus questions have come in KVPY. Okay, so I don't think it's in the syllabus. In any case, I don't know if somehow some question was asked. Maybe it was asked with the intention of asking something else. Okay, but it's as far as I understand, it's not in the syllabus, so you can leave it out. Okay, Arnav. Okay. All right. So once you know the A resultant and the theta, now you can write the resultant wave equation also. Okay. Now if I have written it, so let me write the resultant wave equation. Resultant wave equation now can be written as A times sine of ax minus omega t plus theta. You realize if you do the phasor addition of A1 and A2, which are at a phase difference of delta phi, the resultant phasor A is at an angle of phase of theta ahead of A1. So that is why I could write it like that. Okay, no problem. Okay. Okay, here. So this is what I was trying to say. If when you add two phasors, A1 and A2, the resultant phasor will be theta ahead of the phasor A1. So all I need to do is to judge the phase of the resultant wave. All I need to do is, okay, let's wait for it. Yeah, so what I need to do is I will realize the amplitude, resultant amplitude, and I will realize the phase. The phase would be ahead of this phase by theta. I mentioned this phase and then I added theta. That is how I got the phase of the wave, and I also got the amplitude. Okay, so yeah, just hang on. Let's try to rectify this because every time I'm writing, it's not visible. Yeah, now it is. Now it's fine. Change the settings a bit. So this is how you find the resultant wave equation. Okay. This is the wave that results from superposition of these two waves y1 and y2. Okay, all right. Now, what you will realize is that if when two coherent waves are superimposing, then you can also find the resultant intensity. So, if you remember, the logic we use here is that intensity is in directly proportional to a square, or I can write I is equal to ka square. So you realize from this expression, I could have written a square was equal to a1 square plus a2 square plus 2a1 a2 cos of delta phi, cos of phi here. So in this case, if I multiply both the sides with k, now you realize this can be written as the resultant intensity, this can be written as I1, this can be written as I2. This now k into a1 a2 can be written as root of ka1 square into ka2 square, right? So this will become root 2 root I1 I2 cos phi. So this is how you can relate the resultant intensity also with the individual intensities of the waves. Okay. Now, when two waves of equal frequencies and nearly equal amplitude traveling in the same direction, having the same state of polarization in a medium superimposed, then intensity at different points is different. That is what I realize. What I realize is that at different points, depending on the value of phi, you will get different intensities. Okay. At some point, the intensity will be large, and at some point, the intensity would be, in fact, nearly zero. And this redistribution of energy due to superimposition of two waves That is what you're calling interference. So there are two kinds of interferences of waves, which are constructive interference, which produce the maximum intensity, and destructive interference. Okay. So let's talk about constructive interferences first. What is happening is, I will tell you what is happening. So let's try and visualize this. You have one wave traveling here and one wave traveling here. So when they reach a point, they would reach the point at a certain phase difference. Now, depending on what phase difference they reach there with, they will form some resultant. Okay. Now you realize if you have a source here S1 and if you have a source here S2. So imagine that these two are initially emitting waves of these which are in exactly the same phase. Now, as you know, they travel to different points. As they travel to different points, they reach there with different phases. Why am I saying that? I'm saying that because if you realize the phase can change in two ways, right? For any wave, the phase can change with x and the phase can change with time. Now, I keep the omegas exactly the same, so I will assume that the time taken is almost same. Okay, and in any case, when two waves are reaching 2 points, the time difference is negligible. So the phase difference produced due to time difference would be almost negligible. However, the x's may be significantly different. So the phase difference due to different distances traveled would be there. Okay. So that is why when waves reach different points, they will have different phase differences between them. So if the phase difference is or phi is 2 n pi, then you realize I will see that the maximum amplitude is a1 plus a2. Okay, if you keep here, you want to find the maxima of this, so you can take this as 1. So if cos phi becomes 1, then you have the maximum amplitude, which will be a1 plus a2. Okay. Now, this is the condition that you call constructive interference. So this is it here shown in the diagram. So you realize these two waves are in fact in phase with each other. So their maximas and minimas and means are coinciding. So they are in phase with each other. So two waves which are in phase in each other result in a wave which is higher. Okay, so red one is the higher. There is blue and green, that is the interfering waves. So here you will see a blue wave and a green wave. So these two are interfering and producing the red one, which is called the superposition result. Okay, so at these points where the constructive interference is happening, you will realize what will be the effect. The effect will be that the amplitude would be maximum and hence the intensity would also be the maximum. For these points, obviously the condition is that cos phi must be 1. If cos phi is 1, then the condition is that delta phi must be 2n pi. And I can also say the path difference is n lambda. Why? Because if I remember, delta phi was k delta x. Okay. So if I use that condition, so delta x is what we call the path difference. It is the difference in the distances traveled by the two waves. Okay. So you realize when a wave reaches from here to here, its phase has changed by kx1. When the wave reaches from here to here, its phase has changed by kx2. So the difference in the two phases is kx2 minus kx1. Okay, and what you realize is that this is 2n pi and this is 2 pi over lambda. So that is the condition for the constructive interference. For constructive interference, the path difference between the two waves must be equal to n lambda. Similarly, you have destructive interference. That is when the two waves meet completely out of phase with each other. Now the amplitude would be minimum and it would be a1 minus a2 or mod of a1 minus a2, let's say. Okay, and the intensity will also be minimum. If for such points, again, cos phi has to be minus 1. So pi would be 2 and minus 1 pi, and hence the path difference would be odd multiple of lambda by 2. Okay, again, this is a revision. So I'm quickly going over this. I hope you had studied this once, and I'm just quickly talking about this, not explaining it too much here. Okay. Next, you have a question related to interference. Let's see how to approach this one. This says two waves of equal frequencies have their amplitudes in the ratio of 3:5. When they are superimposed with each other, the result Calculate the ratio of the maximum is to minimum intensities of the resultant wave. So let's try that. Now this ratio is also called the contrast ratio. The ratio of the maximum is to minimum intensities is called the contrast ratio. That determines how distinctive the maximum and minimum intensities are. The bigger the contrast ratio, the easier it is to distinguish between these 2 points, right? The greater is the contrast achieved. If the intensities are very similar, then they appear very, very similar, right? So contrast means one should be very high, one should be very low. That is high contrast. Okay. So try and figure out the contrast ratio. Okay. What do you think will be the answer? Let's see. So hurry up, people. कहाँ खो गए भाई सारे? कोई तो आंसर करो यार, सिंपल सा सवाल है. अभी जो फॉर्मूला बताया तुरंत का तुरंत सोचो, प्रैक्टिस करो, एक दो सवाल करके देख लो भाई. इट्स इम्पोर्टेंट. So anybody? Okay, let's see. कैसे करोगे? So you've been told the ratio of the amplitudes is this and this. Let's assume that a1 equals 3x, a2 would be 5x, correct? A max कितना हो जाएगा भैया? A max हो जाएगा 8x and A min would be 2x. Okay, A max is A1 plus A2 and A min is mod of A1 minus A2. Correct. Now you know the intensities. Okay, 16 is to 1. Yeah, that is the correct answer. That is the correct answer. I max would be K A max square, and similarly, what you will realize is I min equal to K A min square. So what you realize is I max is to I min is nothing but A max is to A min whole square. That is 4 square or 16. So well done. Yes. Correct answer, guys. All right. Let's move on to the next question then. So again, it's the other way around now. If A max is to A min is alpha, find the A max is to A min. I max is to I min has been given to you. So this is very simple. We just did it. So all you need to do is root of I max. This will be root alpha. As simple as that. Now, if you know this, then you also know this is A1 plus A2 or A1 minus A2 equals root of alpha. Correct. So from here, obviously, what you will realize is that part B, what I will see is A1 times root alpha minus 1 equals A2 times root alpha plus 1. So A1 is to A2, the root alpha plus 1 over root alpha minus 1. Okay. Now again, the last part is also simple. I1 is to I2 square would be equal to square of this. I1 is to I2 would be simply A1 square is to A2 square. This will become square of this. Okay, so that's it. That's it. Very easy question. Okay, this is a typical kind of a problem that is asked from interference. Okay, so try and answer this one now. In an interference, two individual amplitudes are A each and their intensities are I each. Find the resultant amplitude and the intensity at a point where the phase difference is 60 degrees and where the path difference is lambda by 3. This is a very typical question and this is the one that you need to be practicing. Okay. Okay, let's see. Okay, so AP says root 3A. Okay, let's see. Okay. So again, if you'll have to remember the formula that we discussed in the last class. Okay. So if the two amplitudes were equal, then if you remember, A resultant is 2A cos of delta phi over 2. I hope you remember that. Right. So in the first case, the phase difference is 60. So what is going to be A resultant? A resultant is going to be is going to be 2 times A into cos of 30 degrees. So cos 30 is root 3 by 2. So yes, root 3A is the correct answer. Okay. Yes. And you also know I resultant would be K A resultant whole square. So this will be K times A square, and which is equal to 3 times I. Okay, because K A square would be I. So yes, 3I and root 3A are the correct answers for part 1. Similarly, for part 2, let's see, the path difference is lambda by 3. So let's try and calculate the phase difference. Now you know delta phi is equal to A delta x. Okay, again remember this. So what will happen is K is 2 pi over lambda into lambda by 3. So the delta phi that I'm getting is 2 pi over 3. Okay, so that is 120 degrees, right? So A resultant would be 2A cos of pi by 3. Cos pi by 3 is 1 by 2. So what you'll realize is resultant amplitude is A only. And if the resultant amplitude is A, you realize I resultant is I. Okay. So yes, well done. This is how you would have gone about it. Okay. I hope that is clear to all. All right. So that is it. That is what I wanted to discuss about interference. I hope everybody followed this. Again, interference questions are usually very simple. All you need to do is find out the path difference, and again you do study that in wave optics also, so you get a lot of practice. So now next whenever you are trying to do, remember these equations in the interference results. Okay, one is your phase difference is equal to k times delta x, where delta x is the path difference. Okay, then your resultant amplitude is going to be 2a cos of delta phi by 2, and of course your intensity is going to be, resultant intensity is going to be, if you square this, so 4 times I naught cos square delta phi by 2. Again, you might even remember these equations from your YDSE calculations. Okay, just remember these. That is it. These are the important calculations. And for constructive interference, what was the condition for constructive interference? Your delta x should be equal to n lambda, and A resultant would be equal to 2a naught, and I resultant for constructive interference would be 4I naught. Okay, the amplitude gets doubled, and hence the intensity gets 4 times. For destructive interference, the condition was delta x equals 2n minus 1 by 2 lambda. Okay, so obviously A resultant here would be 0 and I resultant would be 0. This is assuming A1 equals A2 equals A. Otherwise, I told you. But most of the cases, we will treat them as equal amplitudes only. The reason why we treat the amplitudes to be equal, so this is one last thing that I wanted to tell you, was we said that A1 should be equal to close to A2 for interference to be observable. Now, why did I say that? So what is interference going to do? Interference is going to change the amplitudes at different points. So you realize A max was A1 plus A2 and A min was A1 minus A2 in mod, but I'm not bothered about that. Suppose if A1 is much greater than A2, then what you realize is that A max is roughly equal to A1, which is again roughly equal to A min. Now the problem is if the amplitudes are close to each other, are not close to each other, if one amplitude is way higher than the other, then the interference is not observable. The interference is happening, but you won't be able to observe it. The reason is because the maximum amplitude and the minimum amplitude almost will be equal to the amplitude A1 only. So that is why the condition for observable interference is that A1 should be close to A2. This is condition for interference to be observable. This is not the condition for interference to happen. Interference will happen even if this is not true, but it won't be observable. You won't be able to observe the variation in the amplitudes. All the amplitudes will almost look the same to you. Okay? So that is all that I wanted to discuss about interference today. And next we will talk about standing waves and beats. Till then, you guys go and practice some questions. Okay. So that is where I would like to wrap up today's session. And before I wrap it up, let me remind you that if you haven't gotten your Unacademy subscriptions and you're planning to, then this is how you can go about that. So you can go to the plus section of the app, select your goal as IIT JEE and click on the get subscription button. Okay. When you do that, you will be redirected to the payment page where you will find a box which will say, do you have a code? So the code you can enter is RD Live. So this code will give you a 10% off on all your subscription fees. Now you can choose from two kinds of subscriptions, which are Plus and Iconic. So the fees of these subscriptions have been mentioned here. Now you can choose any plan that suits you. You will also realize when you click on proceed to pay, you get a lot of no cost EMI options to break these payments and into smaller parts so that you're not feeling the pinch or the burden of the payment at one go. Right. Next, students can now also choose, as I said, Plus as well as Iconic subscription. So those of you who don't know what the Iconic subscription is, let's tell you a bit about that. The iconic subscription is something that will take your IIT JEE preparation to the next level by allotting you personal coaches. So from our team of experts, you will be allotted personal coaches, and along these personal coaches will closely mentor you and guide you throughout your IIT JEE journey. Along with that, you will also be attending a lot of IIT JEE workshops, receiving expert guidelines from time to time, getting a study planner, which I know is very, very important for a lot of students who struggle to plan their studies, okay, and get regular test analysis sessions. So with all these additional features and the personal guidance of your personal coaches, trust me, you will power through your IIT journey, and definitely it will take your IIT preparation to the next level. Next, the students who have just entered class 11th and are confused about how to, go about their studies can now go for combo subscriptions that Unacademy is offering you. So Unacademy offers you now 4 combo subscriptions, and any of these combo subscriptions takes care of your CBSE 11th studies, CBSE 12th, and hence boards, your JEE Mains preparation, your JEE Advanced preparation. So every preparation that you might be bothered about, when you've entered in class 11th, will be taken care of by any of these subscriptions. Depending on your personal need, you can now choose from 4 subscriptions. So the first subscription offers you the iconic subscription for IIT JEE and the plus subscription for class 11th and 12th CBSE. This subscription starts at around 4,600 a month. The next subscription offers you the iconic subscription for all 3. This subscription starts at around 500 a month. Next combo offers you the plus subscription for IIT JEE and plus subscription for CBSE as well. This combo starts at around 3,000 a month. And finally, you have a combo which offers you the plus subscription for IIT JEE and the iconic subscription for CBSE 11th and 12th. This subscription starts at 3,900 a month. Now, depending on where you think you need to focus more, you can select a suitable plan for you, and then you won't have to worry about any of your studies for the next 2 years. They will be taken care of. Okay. Next, this is a list of the upcoming tests in January, so make sure you're not missing out on any of these. So these present you wonderful, wonderful opportunities. Okay, so the next Unacademy Combat event is going to happen live on the 31st Jan. You guys know, if you do well in the Unacademy Combat, you can win a lot of cool prizes. Then the race test is going to happen on the 4th of Jan. Okay, so make sure you're not missing out on that also. You have AIM Advanced 2021 tests, which are happening every Saturday. Again, very, very important for all 2021 aspirants. And then you have unique DPP discussions, which are going through every Monday to Thursday. Again, you do not want to miss out on these, okay? Now, if you like today's session, then do not forget to press that like button and share it with as many people as you can. So we at Unacademy realize that not all students can afford these subscriptions. So it is your duty, if you are benefiting from these videos, then share it with as many people as you can so that others can also benefit from this. If you're new to the channel, don't forget to subscribe to the channel to keep receiving the amazing content being provided here on this channel completely free of cost. And do not forget to press the bell icon. Though often that doesn't work, okay, but still, do not forget to do that. Now, the PDF of all these slides used in today's lecture would be available for download very, very soon. Okay. Now, students who are following us on the Telegram on the JEE English channel of YouTube can connect with us on the Telegram app using this link, so that you're not missing out on any of the amazing sessions and lectures happening on this particular channel. There are also a lot of useful links given below in the description box, or do check them out. So you have a lot of links about new batches and again new offerings that Unacademy has to present. Okay, so do check out the description box and do go through those links. Okay. And finally, this is where I take your leave. And before I leave you, let me remind you one last time that this is my referral code RD Live. So if you want to take the next time you are planning to get your Unacademy subscription, you can use this code and enjoy a 10% off. All right. So with that, I'll take your leave. We will now carry forward our discussion next week, from next Friday. Okay. Till then, you guys keep studying hard and keep practicing hard. Okay. And definitely take good care of yourselves. Bye bye and take care.